So hi guys, I am Parampreet Singh. I am a Python developer and I am doing this iit-bs degree, and I'm in the end of diploma term. I have been taking MLP sessions in the last year May term, um, with the collaboration uh, in the collaboration with GIR House. So today's session is also in the collaboration with GIR House, and today's session is about regarding the end term revision. So today we will mainly cover the topics, all the topics mainly for the end term through PYQs. Okay, so we will solve PYQs live, and then we will if you get any kind of doubt in between, you guys can simply ask. Okay, so let me just share my screen. And just one thing, guys, please be responsive throughout the session. Okay, this is just one requirement, you can say, I need from you. Yes, I'm recording this session and I'll upload the recording of this session in my YouTube channel. This is the YouTube channel. You guys can simply just search it or subscribe it. Okay, I'm sharing the link here. And okay, it would be helpful if you guys can interact through reactions, through chat, or even if you can speak, that would be great. Okay, so shall we start? Okay.
Yep, we can start.
Okay, so the font size is clear.
Yeah, the font size is good.
Okay, okay. So we are having these four PYQs. First is September 2024, then May 24, then Jan 24, and this is September 23. Okay, so we'll try to cover most of these. All right, and if you get any kind of doubt in between, you guys can simply interrupt me and ask. I'll explain you. Okay, so first let's start with the September 2024 end term. The first question is very basic. It is asking for the number of columns after applying one hot encoding to the data. Okay, so the correct answer is written here already, obviously. But I just want, can anyone explain me how many columns we will get from each of the columns? So here we have two columns. One is, we can say, for the fruits, and other is some number. So how many individual columns do we get, like for the first column and for the second column? Or anyone can explain? Um, okay.
Three,
3, 4,
first column.
first column. Okay. And how three? First is the apple. We in one hot encoder, we mainly figure out how many unique values do we have. Okay. And based upon each unique value, we create those many unique columns. Okay. And for the second column, this number, how many columns do we have? Like after applying one hot encoding?
Three columns again.
Okay, right. And just one thing, what values do we have in our data frame after transforming it with one hot encoding?
Ones and zeros.
0 and 1, right? One is there where one wherever these values will match, one will be there, and in the rest of the columns and the rows we will have zeros, right? So this is a very basic question. The 2 marks, very easy.
I wanted to ask what would be the answer if the sparse output was true instead of false.
So the sparse output just okay, sparse output is just like, how do we want the output should be. Like by default it gives us a sparse matrix. So if we set it to false, we get a data frame directly. Okay, whatever
So
data
will the
we are
answer
passing.
change or will it not?
Sorry.
Will the answer change if we set it to true or
No,
will it not?
no, answer won't change. I I'm not sure about the shape is exactly the attribute we will work with after sparse output is true. I think it will be, but yes, generally it it is just we will get a matrix. Sparse matrix is kind of a special matrix where like we can just see the object mainly, like we can say we can just see the shape, how it is defined, not exactly the data. So just to like for further computation for general purpose we set sparse output to false.
Hello,
Yes.
hello. The number of columns will come like there's five of them is like categories, and one is numeric value, right? That is the
uh
total.
no. So like we have two columns as of now, right? The first column is of what we
These are
can say,
categories.
yeah, first column is of category, second is of some
So,
numbers. So each
okay.
column will be divided into the columns, the number of columns as per how many unique values do we have. So for this, like we have apple, banana and orange, three unique values, so we'll get three columns. In the second one we have three unique values, 3 1 2, right? So we'll have three unique columns here as well. So in total six.
Okay, okay, yeah.
Okay.
Yes, got it.
Now next one, the scaling one, min max scaling and standard scaler. Okay, so they are just simply asking us to use min max scaler, and then after that applying that to the to the data frame, and then we need to get data max. So this is kind of the max value for each of the column. So we just need to figure out what's the max value in the first column and what is the max value in second column. So here like we have 8 here in the first column in with the respect to all the rows, and for the second column we have 6. So this is just a very basic answer. Just one thing, guys, there are so many attributes in so many attributes and functions in each of like these kinds of classes, these kind of pre-processing methods. Okay, so it is not necessary for you all to like uh, read all, और let's say सबको याद करने की ज़रूरत नहीं है. ओके, सारे फीचर्स को just that just take a very basic intuition like what that can do. Okay, so like before this I have never used this data underscore max underscore, but as the name suggests, it is asking for, it is like giving some maximum value of the data, okay, the attribute itself. So this is how we can figure out, and we also have the options, so that would be very easier. Okay.
Yes. One more thing that I have noticed with this is that
Mhm.
the questions often repeat.
Yes.
If they have asked data max once, I'm sure they'll be asking it again. So
Yes.
they repeat the functions that they ask. So you can
Right.
take it as a kind of training data, this PYQs itself,
Hmm.
and train yourself what kind of questions they'll ask.
Right. Right. That is like very with a high probability we'll get. So the next question, this is, I guess this has been repeated since last 2 years, or we can say 6 terms. We You have loaded a dataset with 1000 samples, 20 features, some of the samples having missing values for few features. If you want to remove rows with fewer than 15, okay, with fewer than 15 non null values, we'll use draw pane, but thresh equals 15. Can anyone like explain why we are using thresh equals 15? Why not thresh as 5? Like we have 20 features and we want to remove with rows fewer than 15 non-null values. Anyone can anyone explain?
Threshold acts as the minimum cutoff for which above which the feature will stay. So as
Mm-hmm.
per the question, we have 15
Mm-hmm.
non-null. That means there should be some
Yes,
values in the features.
right, right. And yes, Harsh, you are also right. So that's why we are using this. Okay, it's a
Sorry,
very
I don't get it. I
uh,
don't get it.
okay. So
Could
we
you
set
explain?
like a, you can say a breakpoint, or and here like we have 20 features, so we are setting the breakpoint at 15. So we want to remove all the rows which are having less than 15 non-null values. That means more than 5 null values if we have in a particular row. Okay. So we want to remove those rows wherever we have more than 5 null values. Okay.
For each row, if that row contain more than
5.
5 null values in columns.
Mm-hmm.
If the 5 columns are null values, that should be removed.
Yes.
More than 5.
Yes.
Okay.
Yes. Okay. So we just need to understand what they are exactly asking. Sometimes they ask in this manner, sometimes they ask in the opposite manner. Like they provide us the direct value, like we want to keep only the rows which are having, let's say, uh, 18 non-null values or something, or let's say we want to remove those rows which are having 2 null values. Okay, so in that manner we just need to figure out what threshold value should we need to use. Okay, that depends upon this, like this part of the question. Okay, Harsh is asking something. The thresh is the
Yes.
number of nulls or number of non-nulls? Number of non-nulls. Okay,
Uh,
you
Param, I'll
yes.
explain one more thing
Mm-hmm.
that will make it much more clear.
Mm-hmm.
So, first of all, this is drop NA. NA means null. Thresh literally stands for threshold.
Mm-hmm.
And 15 here refers to how many values are non-null.
Right. So we are
Okay.
just setting a limit that how many non-null values do we need, at least how many non-null values do we need in a specific row to keep that row. Okay, if that criteria doesn't match for some row, we'll remove that row. Okay, it's a very simple thing. Is this clear to you all, what Vignesh and I have uh, explained? Okay, all right, so now let's move on to the next one. Mean absolute error. So we just need to find out the mean absolute error. Can anyone tell us the formula? What is the formula of mean absolute error?
Mean absolute error is like a number of
Okay, I'll write it. You can like explain that term.
y
Sigma yi minus sigma y bar. That's
Mm-hmm.
its absolute value
sum
divided
of
by
all
n.
Yes.
where
So here we'll take the absolute. Okay, and divided by m, which is the number of samples, we can say. And this is for all the samples we have. So this is it. We have like MSc, MAE, and other various metrics, and they are just asking for MAE. So we just need to um, set these values in this formula, and we'll get the answer. And okay, just one thing. Um, in this absolute and in as well as in MSc, where we take the square root. Okay, square. Okay, it doesn't matter like where you would keep the true values or the predicted values. Okay, because at the end, in one scenario we are taking the absolute, in other scenario we are taking the square. Okay, so this is a very basic thing, sometimes we often get confused. So okay, um now the next one, this is just you can calculate right afterwards. Then the next question is, we are given some data x and y. Now we are implementing SGD regressor with the learning rate as constant, which is 0.1, and maximum iteration is 1000. So learning rate constant they are asking, it defines the initial value. Yes. So um, again the same thing. We don't need to remember all the parameters, all its values, like what they mean. The libraries have made it like are made very we can say user friendly. We can just read out the code and we'll understand what exactly it means. So eta 0, everyone knows this is the value for learning rate, right? What learning rate do we have and what type of learning rate we want, that is constant as we have specified. So it means it will stay same, it will keep it constant throughout the whole training. Okay, so again a very basic question. So let's move forward to next one. um then what is the primary purpose of n estimators parameter in bagging classifier? Okay, um again, um if you know what is bagging classifier, how it works, or even just a very basic intuition you have, you can get an idea. Like if you have used any kind of tree model, you know what n estimator means. Okay, can anyone tell me what does n estimator mean? Like what we are representing by this value if we set it to, let's say, 10. Anyone?
Is it like distributing the data into discrete bins, into 10 separate bins?
No.
Okay, maybe I got confused with others. Sorry.
Okay, so estimator is means how many, we can say, models do we have exactly, not exactly the bagging classifier itself 10 times, but it means some base model. So like we all know like random forest, if we say, if we take RF model, we have like some decision trees here, right? Decision tree 1, decision tree 2, decision tree 3. We have like various decision trees based upon different values. Like they all have some different criteria on how they are splitting the data, right? So an estimator is does just mean that how many decision trees we need in the case of this random forest, and in the case of bagging classifier as well, what the base classifier which we are using. Base classifier can be different, it can be same, it's up to us what we are specifying. So it's just like again the second option. It controls the number of base learners, or it is, they have also mentioned models. So how many models do we need to train in this ensemble? Okay, again a very basic thing. So are you guys clear with this?
Actually, I'll ask another question, and you should not answer this. Others should answer this. What is an ensemble model, first of all?
That is interesting. Anyone?
Like it uses the weak learners and create one stronger model for it.
Okay, anyone else?
Okay.
Well, it is in the we can say the whole tree-based models, we call them as ensembles.
Yes,
And
I'll still like to give a more formal definition for this. Basically, an
yes.
ensemble model is an approach that combines the predictions of multiple models to produce a single, more accurate prediction. One good example, which Param already gave, was of random forest. Then we have gradient boosting. Then we have bagging classifier itself, which is there in the question. What happens in random forest? We make several trees, right? N estimators
Mm.
uh, here would be the number of trees. So n estimators just tells how many different models within a single big ensemble model do we have to make.
Okay, everybody got it?
Yeah.
Okay. Guys, just please be clear with your basics. Okay, these are very necessary. I was just expecting कि कोई ना कोई option से देख के ही बोल दे what does that ensemble mean. Um, but okay, it's fine. So and thank you Vignesh for for your help and explaining. Okay, so now let's move on to the next one. Again, we have ensemble, bagging classifier, and we also have a tree based model, decision tree classifier. So the same thing which I was just saying earlier, we can set a base estimator. Here we are setting base estimator as decision tree classifier. Okay, and then we are setting some other values, the n estimator, max samples, random state, and everything. Now max sample. Okay, before going to the options, anyone can please explain what each parameter mean here? We can just if you know the definition of any this ensemble or tree based models, you can guess it. Even if you know for any one thing except n estimators. Okay, let's talk about random state. Can anyone tell me why we set random state to some value?
Yeah, for each times of training, it will give the same.
It will give the same.
Uh, it will trains on the same set, like
Mm-hmm.
For every iteration in the
for
model training, it will take the same value of set and it will give the same output. It will
Yes.
not take different data sets and produce different output every time.
Hmm.
yeah.
Yes.
Correct. I'll also like to draw a parallel here. Just like in, if you guys have studied Mad 1 or Mad 2, there was something called as setting up an environment so that the whole, whatever we set up, it does not fail. Similarly, this random state just make sure that everything that we do, it is the results are reproducible. They don't change with every implementation every time we run it.
So you all might have used train test split, right? How many of you know about train test split? It's like the very first step in which we use random state.
I think most of them knows.
Yes. So that in that train test split also we set some random state value, right? Just to keep the data as in like in the same manner, so that as an okay we say in my computer it works, in yours it doesn't. Okay, so just to keep the uniformity, um, we set some random state value so that we get the same data again and again. It doesn't like randomly just uh, it shuffles the data and everything. So it follows some parameter. And what about max samples? That is the main question. What does it specify?
Is it like what percentage of data we take to improvise upon in every iteration? Like, for example, we
Mm-hmm.
have zero point 0.5 here, so
Mm-hmm.
that means 50% of data can be replaced and taken for the next iteration to improvise the model.
Okay, 50% is correct. Like
Okay.
you are half correct, we can see. Anyone else? Just a guess. Okay, so max samples is just as Jeevan said, we take the 50% data, but in all the like the base estimator which we have defined here, decision tree classifier, we pass in the 50% data. That doesn't mean like we pass the 50% data in one decision tree and second decision tree, and rest 8 decision trees will left them out with zero data. No, we just pass in some like 50% data and then some other 50% data. Let's say we have 800 samples, so we give each estimator as in 400 samples. Okay, that would be in the different, we can say, proportion. Okay, so the percentage of training sample used to train each base estimator. This is what max sample can say, the proper definition. Okay, anyone has any doubt in this? Okay, great. Now in random forest classifier, what effect does setting the max feature parameter to a higher value? Okay. Well, answer is right in front of us. Can anyone tell us what max feature does in do in random forest classifier?
Maximum number of features used by each
Each?
base estimator
Mm-hmm. Okay.
during
Okay. Uh, so yes, we can say that obviously. What effect does setting the max feature parameter to a higher value? Okay, so if we set some max feature to, let's say we have 20 features and we, well, we cannot set it as number. Yeah, okay, we can set, I guess. So let's say if we set max features to 20 only, then what will, like, how it will affect the model overall? It's a very, we can say,
If we
stats
take
problem.
more features for training, firstly, it's computationally more expensive, and we have features that are not very, what is it called? That are not very significant. So it reduces the low signifying features and it helps avoid underfitting.
But
Someone wrote in the comments that it might lead to overfitting.
and okay, who else wrote? Okay, Lakshya, can you explain it?
So if we have features that do not explain the data well, and those are also included, so it will make the model overfit on the data.
Right, right, exactly. And when overfitting happens, like in the bias variance terms, how can we explain overfitting?
High bias covariance.
Oh, underfitting, low bias, low bias.
Okay. What about variance?
Underfitting, high variance, low bias.
Are you sure?
I had said it, I had forgot.
Okay. Anyone else? Just think about it, like overfitting कब होती है?
When it is very general, so I think overfitting is when the variance is low.
It captures the structure.
Okay. Okay, just one thing. Let's take the example. Lakshya said, right? Overfitting. So when and before that, Sahad, you had said, I guess. So let's say we set the max features to all the values which as the number of features we have. Okay, so we will have like more number of trees. Like we have, we can say we'll have a bigger distribution, right, which will include some unwanted features as well. Okay, and that will lead to, let's say, normally if we set some max features to some optimal value, we'll get some data, let's say, uh, closer some with a very good with a very good accuracy. Good accuracy means the variance is low. Okay, like it is not overfitting, it is not underfitting. We are having kind of we are in a very mid state. Okay, and when we add some randomness, like these unwanted features, this will eventually increases, like this will eventually spread the you can say predictions, which will lead to high variance. Okay, so this is the analogy which I guess Sahad had said in starting, that will lead to more unwanted features. That we if we follow up with that only, we'll get the answer like what will happen to exactly with the um, data. Will it what will happen with the biasness and the variance? Well, in biasness, we cannot say it will increase the bias. It will, in fact, like it will keep the bias as in lower, because we still have the wanted features which will like keep the data in the proportion where we want it. So bias simply changes uh, the direction, we can say, of the data, right? Variance is spread out how depends upon how big the variance is. So this is a very basic we can say analogy कि जैसे जैसे we increase the randomness in our data, or let's say in our models, the accuracy will be lower and lower, and it will eventually leads to, like, the more randomness means more variance we have, the more data is spreaded, or the more predictions are spreaded. Okay, is it clear to you all? Okay. um okay, anyone has any confusion or something? Mm, okay. Should I explain it again, or should we move on to next question?
We can move on.
Okay. Okay, it decreases. It eventually increases. Okay. Uh, I guess maybe I got some confused or something. Okay. Now next question is, you are working with the dataset of customer purchase behavior with total amount spent and number of items purchased. We have to separate the segregate the data like into different segments of the customers based upon how much they spent and on like upon the quantity. Okay, we have this code here. We have the data with the total amount spent and the quantity, and then we have the labels and the centroids. Okay, based upon the given, what does variable? Okay, it's a very basic question. You all must have used k-means. What does the label represents? Anyone? Okay, किसी ने k-means नहीं करा?
It's
Uh,
like
Sir,
where
it tells the cluster basically to which cluster it belongs.
that specific data, uh, to which cluster it belongs, right? And cluster centers, what are those?
mean of cluster,
It's like the
the mean of
centroid.
elements of the cluster.
Okay. Um, cluster center is basically okay, as it is written in the comment, centroid coordinates of cluster. So like where that cluster is, yes, we can take the mean, yeah, because it's k-means. So where that cluster is located, that with the label we can identify which cluster is that. And yes, variables are cluster assignments, which group each customer belongs to, right? And each customer we have as in a row. Now next one, MLP classifier we are working on, and you are concerned about overfitting due to the complexity of the model. You have decided to increase the alpha parameter to control overfitting. Okay. First of all, what does alpha do?
Isn't
Regularize.
it like the learning rate?
Mm-hmm.
Whenever we have any error in the model, we set alpha, and alpha does the backpropagation and changes the weights accordingly. If the alpha value is high, we might miss the local minima,
Mm-hmm.
but if the alpha value is very low, the learning rate will be very slow. So
Mm-hmm.
alpha value is like the learning rate. If it is high, learning rate will be more. If it is low, learning rate will be less.
Okay. It is more related to regularization, which eventually like leads to learning rate.
Yes.
Okay. Then what is the effect of as you have already said, if alpha is high, we'll get it adds a stronger regularization term. And okay, uh, so we have like learned about two types of regularization, right? The ridge and lasso. So if we are setting some value to alpha, by default, which regularization is being applied?
L1.
Sorry.
Lasso regression. Lasso.
Hmm. Um. Okay, it was ridge, I guess.
Sir, I think ridge.
Yes, it was ridge. Let's check alpha in.
By default is lasso.
Okay, let's confirm. Um, L2. It is in the parameter alpha controls the strength of L2 regularization. Yes, it was ridge, not lasso.
Okay.
Okay. It adds a strong regularization term to the loss function, which reducing the model complexity and helping prevent overfitting. The alpha, if we increase it, as Jeevan has already explained. Now, next one. Consider the following two statements. The multinomial naive Bayes classifier is suitable for classification with discrete features. Uh, Two dependent features do not impact Gaussian NB performance. Okay, this I have like I know less about this one. So can anyone explain like okay we have it is written statement 1 is true. The multinomial naive Bayes classifier is suitable for classification with discrete features. Can anyone explain these two statements? Um, okay. I guess naive bias is the um in the like naive bias we have various variations which will come in n term eventually. Okay. Two dependent features do not impact on Gaussian NB performance because internally it calculates the conditional probability. Um, well, it in fact it impacts Gaussian NB performance
But
because we are simply using
it
the
looks
conditional
like a
probability.
contradicting statement itself.
Sorry.
It looks like the statement is contradicting itself.
Hmm.
Two dependent features and conditional probability is calculated independently.
What that's the thing. So yes, the statement two is false directly. And the first one, regarding the first one, the multinomial naive Bayes classifier with discrete. Okay, multinomial. Let me just check it once. For text data predicting the class. Okay, with discrete features. So yes, text data is, we can say, for discrete features. Classification with discrete features. Okay. Okay, in the first definition itself of scikit-learn, it is written the multinomial naive Bayes classifier is suitable for classification with discrete features. If we see, okay, all right. Um, Now next one, the code below fits a pipeline with scaling and linear regression. So we are using the diabetes data and standard scaler, and then we are using linear regression. What is the role of standard scaler? Okay, it's a very basic thing. Anyone wants to take this?
Sir, it will do the scaling part in that the null values will get replaced by the formula x minus mu upon standard deviation of that particular column.
One small correction, it
No,
will not change the null values, it will change all the values.
right. The imputer is used for like replacing the null values. The scalar is just to scale the data set. And why we are,
Yes, yes, sir.
why,
Sorry,
yes.
I got
It is
confused.
scale the data set between the mu is equal to
Hmm,
0 and sigma
right.
variance is equal to 1. Between 0 and 1.
Hmm. And why we use scalars with the linear models?
Because it will, the outliers will not affect the models negatively. If we have
Right.
outliers, the
Hmm.
higher values will affect the models negatively.
Right. Right. So again, the same thing. It scales each feature extend to have with a mean of 0 and standard deviation of 1. That's what the like the formula of standard scalar we have. Which of the following scoring metrics uh, could be used for evaluating a classification model in cross validation using cross val score? Um, okay, just a second. Which of the following scoring metrics could be used for evaluating a classification model in cross validation? Uh, could be used. Okay, for classification model. We do not have explained variance kind of a like scoring metric, right? MAE. When like for which kind of a data we used MAE?
Numeric.
Okay, numeric. And what about R2? Okay,
Regression.
R2 and the MA mean absolute error, we both we use these both of them in the regression and like problem. Okay, as this is a classification model, so the only thing which we can use is ROC AUC curve. Can anyone explain what is ROC underscore AUC? This basically this curve means. Okay, it isn't just a metric. Okay. It is related to, we can say, true positive, false positives.
Oh, the confusion matrix.
Not confusion matrix. It is not a confusion matrix, but it
I
is
mean,
a
it is related to that.
Yes, so let me just show you. Like by showing the curve, that would be much better. Yes, we can take any. Let's check this one. One image, and okay, the image is not clear. Uh, I hope it is clear enough. So we have the true positives here, and we have the false positives here, and like it builds a ROC and AUC curve. It builds like this curve. The ROC is just that this these curves we can say, and the AOC is just area under the curve. So this whole proportion which we have, this is we can say as in the area under the curve. So the better it relies upon the true positive rate, it means we have a better classifier. This image is depicting everything. Okay, so this is what ROC curve is. Um, do you guys like know about the classification metrics, like the mainly we can say confusion metrics?
Yeah.
Okay, what about others?
Yes, aware.
Okay, so yes, mainly ये थोड़ा सा like we can say it is not we have not used it enough, ROC AUC. It is more of for like interpretation of the predictions, and we generally use the confusion metrics and then precision recall and everything. So the next question, linear regression, and we have the y. We are using two regressions. Okay. Um, in in one we have set intercept equals true. In another we have set intercept equals false. Okay. So what does the intercept means?
The biased.
The
Yes,
bias, yeah.
bias. So in first one we are using the bias term. In second one we are not using. Which of the following is true? So the score we'll get is R2 score. In this case, okay. For this case, which of the uh, following is true?
S1 should be greater.
It is. It should be C option, right?
In this question, S1 is greater than S2, no?
Yes, that is what I was
Sir,
thinking.
actually, the TA discussed the paper. In that also this question was there, but digits were different. So in that what happened that there is a relation in the features like 12, 13 means x and y equals to x plus 1. Likewise 23, 24. So in that case, he was saying that relation is there and that like I don't know the exact reason, but he considered this like relation is there among the features, and the intercept will also get calculated. Like that, I don't know the exact reason, but answer is A option only.
Okay, so the coefficients will make up
Okay.
for the bias.
The data. Okay. So the data we have is in some. We can say it is following some series, right? 12, 20, 12, 13, 23, 24, 24, 25. Okay, so I guess this is because of this data we have, like the data is not random, it is following some particular range, some series. So that's why we don't need, like the intercept won't affect so much. Maybe that could be the reason. Um, okay. Uh, well, the answer normally uh, when we don't know about the data or anything, or let's say when the data is random, the answer is always like if the equation, as per the equation, the answer would be the S1 score should be greater than S2, right?
So, sir, how to solve this question?
um Even I don't know like how this explains like the data, if the data is like following some series or something, then we can uh, consider the intercept having is same as not having. I don't know exactly like how they have interpreted it. The answer should be C.
No, the TA what he told is the coefficients adjust for the intercept. So if the intercept or the bias term is missing, the coefficients adjust themselves.
Yes, coefficients adjust themselves. That is correct, obviously.
But
But we have like bias in this y, right?
hmm,
So okay, let's say now we have plotted this, and the S1 where we have some intercept. So intercept means the regression line will start something from here, right?
correct.
And let's take this black one for S2. Okay, as we do not have the intercept, that means the regression line will start something from here, right? It will start from 0, and the slopes, the coefficients, the weights which we have, that will figure out like the line will eventually like how much the slope would be, right? It doesn't tell us like where it will um, we can say where it will coincide with the y-axis, right?
Hmm. Yeah.
So that doesn't explains like exactly this s1 equals to s2, right?
So to solve this, you have to calculate the score manually for all the points.
No, we don't need to calculate all this, because under this the all optimization is being happening. It should be answer C. If anyone has any kind of like if the TA has explained in some kind of, let's say in some discourse post, um, uh, if you guys have that link, please share in the comment, in the chat or in the comment of the video. Okay, I'll like pin it in the comments. The answer should be C only. Now the next one, consider the following code where you apply polynomial features degree equals to. Okay, what will be the output of the code? So can anyone explain what does polynomial features do?
It generates a matrix of 1, x to the power 1, x to the power 2, dot dot dot, up to the degree x to
Degree,
the power n.
right? And we also have like a constant term here, right?
Yeah, x to the power 0, x to the power 1, x to the power 2, and x to the power n, so
Right.
on.
And if we have, let's say, degree, okay, with the degree 2 only, how many features, okay, what would be the number of columns we'll have after applying this transformation on this data set?
3,
Okay,
almost 3.
uh, shouldn't it be 4?
No, that should be rows, right?
Okay, so with the degree 2, we'll have like x1 and okay, we have only one column, right? Okay. We'll have one constant term which is x to the power 0, and then x to the power 1, sorry, and the other one is x1 to the, okay, we'll have 3. Yes, I just like misinterpreted. Okay, what will be the, yes, 3 by 3 matrix will have 3 by 4 matrix for data points. Okay, uh the first one is the constant term, and then we have the features exactly, and then the square of the features because of degree 2. Now the next question, decision tree classifier. What will be the output of the following code? Okay, for this we can just simply make a decision tree, a normal classifier, max depth 2. What does max depth do? Anyone?
Height of the tree.
Height of the tree, right? So how much level, how many levels do we have in that, right? And we can just simply build out in the pen and paper, we can simply build out the tree, and with the limit of max depth, right? So we can go up to the level 2, and then we'll like classify these values based upon this, and we'll have the answer. Now based upon just only this, what do you think, without even building the tree, what do you think would be the prediction?
No, predicting 0.
Yes, 0, right? Because the 2 from 2 to 3, and for the second feature 20 to 30, we are getting 0. So this is in this range. For the second and third data points we are getting 0. Similarly for in between them we'll get 0 here. It's a very basic intuition. Now the following code produces an output of, okay, we have some value. We are using the wine dataset decision tree classifier. Train test split, data is split into 90 to 10%. Okay, how is output expected to change if we decrease the max depth value? Okay, generally if we decrease the if like we change the value of max depth, let's say if we increase or decrease it, what would happen eventually? What will happen?
It should stay the same.
The final accuracy.
Not much effect. It should, in theory, stay the same.
No.
We increase the max depth, like we overfit the model.
Right. It's a very like basic criteria for the tree based models. If we increase the depth, that means we are going deeper and deeper and deeper, right? Eventually we will overfit to the data, training data, and that will lead to lower accuracy. Now currently the code is producing almost 98 to 99% accuracy, right? So if we decrease the max depth, what will happen here? Like we have max depth as 4. Again a basic intuition.
Underfit.
Okay,
And then
underfit.
it will.
Score is increased, like
Yes, the score we can say it will increase, and well that also depends upon the data which we have. Okay, the load wine, we are using the wine data directly. We don't know the exact distribution. It should like output score is likely to decrease. Okay.
Yes, because if we have underfit and if this is the accuracy that we are getting, 98% accuracy,
Mm-hmm.
with decrease in depth, there will be more underfit, so it will become less accurate. So it should decrease.
Yes, sir. The
Yes,
model will
yes.
become
We are
simpler.
yes. We are also like uh okay. Yes.
So I have a doubt. If we increase the max step, then the models would overfit, right?
Yes.
Then the answer is, I guess, wrong, because it will, if it will overfit, then for training data, it will give more accuracy.
For training data, obviously, if we increase the value of max depth, then we will get a good accuracy for training data, right? We are calculating the accuracy on training data.
Yeah, but the answer says otherwise.
No, we
The
are
question is
decreasing the max
the
depth here.
other way.
Okay.
Yeah, got it. I thought that max step was increased. Okay, sorry
No,
for
we
this.
are decreasing. Okay. Now what does the following code? We are using k-means, clusters, and okay, cluster centers and inertia. Anyone wants to explain what does inertia means?
Some squared error.
Okay. Uh, what they're asking. Okay, what does the following code snippet achieve? So outputs the number of iterations. No, outputs the cluster labels. Cluster labels is okay, not we are getting the centroids. So we are getting the centroids, not the number of points. Okay, we are having the centroids from the clusters and centers and the sum of squared distance. Yes, using inertia. So again, if we know the like in a single, let's say a model, whatever values, like what are the basic parameters in in k-means will do, what will eventually happen. So if we know the definition, we can solve these questions easily. uh, what error will the following code produces? Okay, what will happen eventually in this code? The question number 350.
Uh, there are only two data points provided and
Right,
three clusters being generated.
right,
So I guess one cluster will always be empty, right?
right.
So could that be the error?
Hmm. So number of clusters cannot exceed the number of data points. Very basic thing, right? We cannot keep a cluster empty, है ना? Very basic thing in classification. Given the following code using bagging classifier with k-means as the base estimator. Okay, which of the following statement is correct? So we are using the KNN, yes, k neighbors classifier with the n neighbors 5 as in the base estimator, and we are having like 50 of them and some other values as well. Which of the following statement is correct? Bagging classifier will throw an error. As I told you, no. We can pass in any classifier. Each base KNN will be trained on the entire data set. No, because we have set max samples to 0.5, it will train on 50% of the data set. And then sample is trained on the each base estimator. Okay, yes, that is that is correct. And the ensemble will sequential, no, with n jobs equals -1, we are using all the processing power of the CPU. So we are doing this parallelly, not sequentially. So this just one thing. Again, the basic things. Some values we like, some parameters are very common in many of the models, like the n jobs and the estimator in all the tree and ensembles. So again, the very base.
Sorry, sir.
Also
Could
the
you please
random
repeat
state.
end jobs?
Yes. Okay. When someone was saying something, right?
Yeah. Saubhagya, I guess.
Sorry, can you repeat?
No. I said that random state is also common for many classifiers.
Yes. Random stream.
Can you
Your
repeat end jobs, sir?
n jobs means like we can set how many cores of the CPUs should be used to train the model. Okay, if we are setting it to -1, that means to use all the computation power, that means to use all the cores. Okay, so if we set, let's say, n jobs to 1 or 2, and if we have like 4 cores in our CPU, it will use only 2 cores. And like if the data is very big, very large, then it will like first pass in some data, like it will go in some series in sequence. Okay, if we are setting n jobs to -1, it means in all the cores the data is like the training is being divided. Okay, so it will happen eventually faster, but with the more computation power. You are aiming to optimize add a boost classifier that uses decision tree as an estimator. You decided to use grid search CV, and in the learning rate are meant for with, while others are for the decision tree. Okay, so for ADA boost we have an estimator and learning rate, and for others like for the decision the other parameters we want to pass it for decision trees. So how do we do it? It's a very basic notation kind of a problem. Okay. mm, mm, mm. We cannot directly okay, so generally what happens is, like, in a pipeline, if we provide some name, right? In a pipeline, or let's say in column transformer or something, we provide the name that how we should reference it. But in these models we do not provide the names and all, but under the hood it is built in the same manner ki jis way pe we are writing the name, in the same manner we can like kind of we can use them. Okay, like we can retrieve them later on. So we need to pass an estimate, we need to set parameters and estimator and learning rate for ADA boost, and the rest of them will go to decision tree classifier. ADA boost is the main in grid search CV, and it is using base estimator as the decision tree. So for decision tree classifier we have to specify, because it is kind of in the nested level, the second level. Okay, again the basic thing, yes, the base estimator, jo what the parameter which we in which we use, okay, like here also it is not specified, so jo parameter name hai, will reference that, and the values for this will pass in simply. It's a very basic thing. ये I guess आप लोगों ने OPP2 में भी करी होगी, right? For the pipelines maybe. If
Yes.
yes, okay.
Last one,
What's your
base
name?
estimator underscore underscore next.
Okay, this one. So the base estimator is in the ADA boost, right? It is one of the parameters for ADA
Decision
boost,
classifier.
and
Base.
we want to pass in the max depth and criterion to base estimator. So this is like the notation how we set it. If we first provide the parameter, or in pipeline whatever the name we are passing, and then a double underscore. Okay, so this is kind of a notation which we need to follow. um, let's say let's say a common parameter, there is a common parameter we can consider random state. Okay, in decision tree and in ADA boost classifier we have random state. Okay, we want to pass in different values for them. For ADA boost we will simply set random state. For decision tree is being used by ADA boost as a base estimator, so we will pass the value for that random state as base estimator underscore underscore then random state. Okay, similarly to this max depth and criteria. So this is a simple notation thing. Like how do we define the hyperparameters? Yes, Harsh.
We most comprehensive in the sense number of parameters, or
Sorry, number of parameters means?
the question says most comprehensive. So are we testing a number of parameters, or what are we doing?
Yes, we are testing the parameters obviously for hyperparameter tuning. Which of the following sets of parameters is the most comprehensive in testing the capability of? So it is just like they are asking us ki if we use the grid search CV for hyperparameter tuning, we need to set some specific parameters. We want to set some parameters for decision tree as well. So how should we define it? How well should we define it? Okay, so we can use the parameter name, the base estimator. Till this base estimator, this is the parameter name in ADA boost classifier and in other classifiers as well. Okay, so this parameter name and then the uh, parameter in the base estimator which we are using. So this is how we go in nested level.
I am a bit confused in this question. What
um,
took the Adabus parameter and left the decision tree? Uh, why we took the base estimator
okay,
in the first place?
okay, so we have like ADA boost. Okay, ADA boost is using
Yeah.
base estimator as decision tree, right?
Okay.
Okay, and for ADA boost we are passing what values? N estimator and learning rate.
Yeah.
So N estimator and learning rate. Okay,
Okay.
and the rest of the parameters, whatever the parameters we have, we want to pass it to this decision tree classifier. Okay,
Hmm.
now we cannot directly set it. Let's say if we set, let's say, max depth. Okay, in the parameters dictionary, what will happen is the grid search CV will pass max depth to ADA boost, not this decision tree. We want to pass it to decision tree. So this is a like way, this is a notation in scikit-learn, we can say. If we want to pass in some values to decision tree, we'll use the parameter name, this base estimator. So that's why we are using base estimator. That means we are referencing to decision tree. And
Okay.
then if we write max step, that means it this the values in this parameter list will pass into decision tree. Okay,
Yeah.
so this is what is happening.
Okay.
Okay, uh, now the next one, consider the following decision tree. If the tree data consists of 100 samples, 10 features, maximum possible number of leads. So there is a leaf node, so there is some kind of like formula, right? For this we have max depth as 4, 10 features, and what is the maximum possible number of leaf nodes that can exist in the decision tree? Perfectly balanced binary tree. So it's a balanced binary tree. How many of you know about binary tree? Well, each, not each decision tree, but yes. Okay,
Page 16, the answer.
what is the answer? 16. Okay, but what is like there is some formula, right?
Yes, so the formula is the power max depth. In PDSA, I studied
Okay, okay. Yes,
the
yes,
power
yes,
4.
yes. 2 to the power 4. The number of levels we have again the max depth. So 2 to the power 4 will get 16. Okay. Now, which of the following are for dimensionality reduction? PCA. Okay. This is something which is not in the syllabus, we can say. Distributed stochastic neighbor embedding. Lasso regression. Okay, how does lasso is used for dimensionality regression reduction? Okay, there are two type of regularization, right?
Lasso took only those values which features give best result.
Hmm. So lasso basically,
Like uh, quad, like a diamond shape. Here we cut
yes,
on.
yes, yes. So lasso is basically the lasso is L1, right?
Yes.
L1 regularization. So what L1 regularization do is it whatever the features are important, okay, it gives them more importance with the weights, and for some features which are not important to the model, it will take their weight to 0, okay, basically to eliminate those features, okay. So it will eliminate those features, and which eventually leads us to having less features in the final model, okay. So this is what lasso do, but ridge, it doesn't do that. It ridge leads to some weights near to 0. It never makes some weight 0, but lasso makes some weight 0, okay, just to give the importance to the important features. So that is why for dimensionality reduction we can say lasso we can use. Standard scalar we cannot use, right? It's a scaling technique. It is a different than the others. Now, in which of the following cases should partial fit method be preferred? Okay. Yes, these are the basic things when the data is very big, or like when we are getting the data kind of in a not in one go. We use partial fit, like we fit the model again and again and again. We train the model even basically again and again. When data is small, we do not do partial fit, we just directly fit the model. When training labels are noisy, this is a big option. This is not it does not matter with the like which method should we use. Now consider the following code snippet: SGD regressor and some values. So we are using randomized search CV. Okay, these are the values. Which of the following statement could be the given? Okay. uh okay, the font size is clear. I have like reduced it a little.
Yes.
Okay. The first one, the n-iter parameter in randomized search CV controls a number of parameter settings. Yes. So how many kind of like combinations we can try at the end, and the actual number of combination tries to no. The hyperparameter search for the alpha parameter follows a log uniform distribution. Well, that is what uh, param dist log. Okay. Regarding the third
It's
option,
it is given in code, right?
uh,
Log
can you
uniform.
speak a little bit louder?
It is given in code itself, right? Log uniform and the other
Yes.
parameters related to it.
Yes, 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 yes. Log uniform, the alpha parameter, right? And the scoring metric used for the search is negative mean squared. Yes. Again, जो code है, whatever the code is, we are just like interpreting the code itself, nothing else. And what would be the actual number of combinations if they are not 20? We can use these two parameters.
12, right?
How many?
12.
No, not 12. So we can use like uh, the number of parameters settings to try the n iter. So n iter means the at max like 10 combinations, and with the 3 CV that means we will have 30. Okay, 30 combinations to try on. um how do you approach to 12? Not sure.
Once in a session, they multiplied the number of parameters.
No, but
That's why
like
I
here we are
multiplied the number.
using log, right? So exactly we cannot calculate how many values do we have. We have the starting and stop value.
Okay.
um so randomized search CV we only use when we have like a big sample of like the parameters, and we just need to use some few of them, or we just want our model to train faster. Okay, stratified k-fold. Which of the following can be printed during the iteration of, okay, very basic thing, extrain, which cannot be if we set n splits equals to 3, um considering the stratification constraint. Okay, n splits are 3. uh, uh, um, what does n split in stratified k-fold do? Okay, in normal k-fold what does it do, the n split parameter?
Split into three.
Mm-hmm. Split into
At a
3.
stratified K4, like a train test, it is equally split into into three,
Into
three.
3 different data, right? Dis Into the 3 different we can say splits of the data. In stratified it will like keep the distribution, right? It maintains the distribution. Now can be printed. Okay, so like we have this in exchange, what we can have exactly. um okay, very simple thing. Okay, so it maintains the uniformity. Okay, so the for the first option, if we see its output labels, 1 2 3 6 7, um okay, it does not maintain the uniformity. Like here we have how many ones and zeros we have, like the even number of ones and even number of zeros, right? So in the after using stratified k-fold, if we see we should get so these are the x values. Its corresponding y values should also have like the same distribution as the distribution of the base data. Okay, so like here we have, if we map these to the y values, we'll have 3 zeros and 2 ones, okay, which is not following the distribution. 1 2 3 4 and then 5 and then 7, it is following the distribution for um okay, 1 2 yes, it is following the distribution in the like same manner for the y, and for the next one 2 4 6 8 we'll have only 1 values in the y, and in 2 5 and 8 we have the less. Okay, I guess this is more of the based upon the distribution thing. We need some even numbers of values to balance it, because we have the there's an even distribution in the y values, I guess. Okay, anybody wants to explain this?
So then second option 1 2 3 4 5 7, it is not equal. It is two ones and four zeros. And we think why it should be equal na, all the ones and all the zeros.
Yes, that is lacking in the code. Stratified k fold. So let's see. same proportion of samples for each class. Okay, it is not maintaining the same proportion, right? The answer should be 1, 2, 3, 6, 8, 9. Why second is correct? The last one is 4, 5, 6, 7, 8, 9, 9. This is correct. This is okay. Why this is correct? This is not correct, right?
Yes, sir. 1, 2, 3, 4, 5, 7 is not.
If we have like because we have 2 zeros, 4 ones. Again,
4
mistake.
zeros, 2 ones.
Yes. 4 zeros, 2 ones. No, okay. Second option is not correct. The fourth and the sixth option is correct. Now the next one, SGD classifier, maximum iteration. Okay. Again, they are asking about what we are using. This code uses stochastic gradient descent. We are doing partial fit for increment. We can train more data afterwards because we are using partial fit, and the classes parameter is required. Yes, it is required in the classification, obviously, what classes we are passing in the data. Okay, it's a very generic question. And now we are using grid search CV on gradient boosting with these parameters, and CV is 3. Cross validation is performed for each, yes, for each parameter, because we are using grid search CV, so it will use all the combination. And the best parameter, right, it is correct. The number of models will be trained to the number of samples. No, the number of models will depends upon the parameters and CV. And gradient boosting classifier must be explicitly imported, obviously. Again, a very basic question. Okay, how many like total number of combinations we'll have and the total number of models?
4 combinations and 12.
Right, 12 models, 12 classifiers we can say. And okay, the what parameters of k-means clustering algorithm should be tuned? The n cluster, this is the basic maximum iteration. Init, okay, the initialization method. What does init do in k-means? Anyone? Okay. Okay. What does n clusters do?
They define the number of clusters.
Okay. What about max iter? How many iterations should we go for? Okay. Like how many times should we check for the data? Like to which cluster it belongs? Like how many times we are finding out the average of their like neighbor clusters, right? Samples. The init basically is used for where the clusters are initialized. Okay, it can be random, and there are some strategies as well. It's, I guess, k-means plus or k-means plus plus something, and we can also pass in some array of the values, like where the cluster should be initialized. Okay, uh, the each cluster should be initialized. So these are the basic things, and uh, the following code creates a neural network. Hidden layers 5,3 maximum iteration. Okay, okay. I should ask you, how many layers do we have here? Is it 8 or
2
15 or
layers.
2 layers? Okay. And how many neurons?
5 neurons, second layer 3 neurons.
Yes, the basic thing. 2 layers with 3 again, a very simple thing. Now, breast cancer, we are using the data decision tree classifier train to split. We have set minimum sample split to 7, minimum sample leave to 4. Okay. In which of the following scenarios will the split be performed at node n? If the number of samples at node n is 15, if split, the left child will have 10 samples, right will have 5. Okay, minimum sample leaves can be 4. Okay, and minimum samples, when we are left with, let's say, 7 samples, at that time only we can like till that point we can split further. Okay, if we have, let's say, 6 samples, then we cannot go deeper. And if we, again, if we are left with less than 4 leaves in some splitting, we'll stop there. So the left child will have 2 samples, this is not possible. And we'll have 3 samples, this is also not possible. And then the number of samples we have node in 6, no, that is also not possible. So we just need to follow this criteria. Whatever is falling in this criteria, we are keeping those options. Which whatever option is not, we are like excluding them. So it is clear, right? A very basic thing. Okay, I hope it is clear.
So
Mhm.
it is, yeah, min sample split is equal to 7.
Mhm.
So in first option, there if there is n is 15, if split the left child have 10 samples.
Okay. So let me tell you, minimum sample split. Uh, so minimum sample split. That means we should, let's say it is some x. Okay. That means we should have minimum x number of samples. Then only we can split further. Okay. And then we have minimum leaf sample leaves. So that simply is for like, let's say if we have 10 samples. Okay, 10 samples to split, that means we can do splitting, right? Because here minimum sample split is 7. We can do now in what combinations we can do? We can do by keeping this criteria. That means minimum leaves should be 4 in one of the following. So that means we can do in this manner, or we can do in like 5 5, or let's say 4 6. We cannot do something like 3 7 or 8 2 or something. Okay, because the minimum leaves should follow this criteria. Okay.
Yes. But about min sample split 7.
Minimum sample split 7. So okay, if I set it to 7, okay, that, and let's say I have started from here, we have 100 samples, then we have 50 samples, then we are left with 10 samples. uh, before splitting it, before splitting further, it will always check that this criteria is passing. That means this value should be greater than 7. If it is greater, then it's fine, then it will split further. Let's say it will split to 6 and 4, then here it will check, is this criteria passed, being passed? No. So then it will not split further here, and here also it is not being passed, it will not split further. Okay, so these are some basic criterias ki when you should stop, when you should like keep continuing and keep growing, getting deeper into the tree. Okay, some basic parameters.
So like when node have 15 samples,
Mhm.
then we split further into 10 and 5 because min sample split is 7.
Yes, this 15
Then again,
is max.
10 is greater than 7, so again we split.
We can split it further, but we cannot split it this one, right?
5 is not split.
Because the minimum criteria is 7. Okay.
It is 8, then we also split into further.
This we can split if it is 8, but this we cannot. Okay.
But why third option? Okay, it is about child.
Yes, we need to have at least 4 minimum of leaf nodes or child, right? So there are many criterias in decision trees. Again, the base simple criterias, variance thresholds. Okay, we just need to figure out the variance, and if that variance is passing that threshold, we are keeping that particular column. If not, we are not. This is a very basic question, right? We're just checking for the variance and all. And yes, so you guys can like simply calculate the variance for each column, and then see the threshold. If it is greater than the threshold, we will keep it. If it is lesser than the threshold, we will remove that column. Okay,
So
so
it is greater than zero point 0.1, na? All these four
yes, all these for all these, let's say if we have some very
columns.
big
Sorry.
distribution, then it will not like, if the data has more variance.
If the one column have same value, then we
uh,
ignore these things.
Same value means if we have 0.1
Like 1 1 1 1, like yeah, or 2
for
2
1111, what would be the variance?
column. If it is like one column is 1 2 1 4,
Yes, 1214.
it's 1 1 1 1 in one column. In first column, like having all the values are 1.
Okay, so you tell me, if we have like all the values as 1, what would be the variance? How much data is varying?
Variance is like 0.
0, right? So we will not keep that column.
Okay.
Okay, so it's that basic thing. Columns with variance below the threshold will be removed as per it is written in the comment, right? um,
So we
so
calculate variance of each term.
yes, variance of each column. You can also like figure it out easily just by checking the data, and you can cross verify it by calculating the variance.
Okay.
Okay, from sklearn, now we are with the support vector machines. Okay, svc, wine data we are using. And okay, for the y values we have this 0 0 0 for these many, and the predictions are 2 0 0 2 0. Okay, then it is just asking for the score, so we just need to tell the accuracy. So it is we can say 20 40 60% accurate. Yes, so 0.6 is the accuracy. Okay, very basic thing. In classification, the basic the score is class accuracy, the base score is accuracy, and in regression the base score is R2. So this is just one thing we need to keep in mind.
So I could not understand. How did you find out 60 there?
Okay, the actual values are 0 0 0 0, right? The predicted values are 2 0 0 2 0. Three values are matching: 0 0 0 0 0
Got
0.
it.
So the
Got it.
number of values which are matching by a total number of samples is the accuracy, right?
Yeah.
Now, k neighbors classifier, we have these values, and now we just need to predict. Again, we can you create three clusters and we can plot it out. It's a simple plotting problem. Same way for this as well. Okay, most of these questions where they ask us to predict the score or tell the like accuracy or something, we can just simply plot the data, and we can easily figure it out, like where the test data will come, or well the accuracy would be. Okay, um now it is coming in around somewhere here, and I would say it will be in this, like in the centroid for this one. So we'll get 1 as the answer. Okay, 0 as the answer. Okay, so we just need to plot it and with the three nearest neighbors. Okay,
Can you please help us with the calculation?
okay, so 152 63 70 480. So this is x1, this is x2. We have one as in from 50 to 80 and 1 to 4. Okay, let's start from 1 to 4 here, and 50 to 80. So we have okay, not from here. Let's start with some basic from this point. So we have one point here, one sorry, 150 260 370, 150 260 370 and 480. So this is kind of a data which we are having, and we need three neighbors, and the test is 2.5 64. So test is 2.5 and 64. So 64 is aligning somewhere here. Okay, So if you see, it is more closer to the this portion. Okay, and this is having 0, this is having 0, this is having 1. Yes, so this is having 1, this is having 1, because it is 64 in the y-axis, and this is 60, this is 70. 64 is closer to 60, right? So this is just again a simple assumption, and we can like create some random 3 clusters, like one cluster here, one cluster, okay, not one cluster here, and the other cluster is here. And again a very basic thing, from this हमें हमें इससे पता चल जाएगा that 64 is kind of closer to 60, not 70. अगर if it would be 65, then there would be some problem, like in confusion, that the answer will be 0 or 1. Okay, then we need to figure out like how the clusters are, like um uh, in which neighbor it is belonging exactly. For this we don't need to. And okay, if let's say if it is 69, sorry, this just one, what would be the answer?
1, right? Or closer to 70.
Yes,
1.
then it would be 1. uh See, बहुत basic है, whatever the data we have, just plot it out. Okay, and just try some intuition that how it will work the k neighbors classifier. So it will use the nearest neighbor, so it will use 3 nearest neighbors. So out of 3 nearest neighbors, 2 are voting for 0 and 1 is voting for 1. So we are having this 0, right? Now the sales, we have some data. And okay, which of the following commands will return total scores across all the regions? Total sales, so we just need to sum up the sales, basic thing. Which of the following will return the name of employees in the north region? Okay, so first we need to filter it out with the north and names of employees, then we need to use the name column. So we just need Alice and Ivan. So first we will check with the north, like match the filter, we'll create the filter. This is the appropriate way, and this is the appropriate way with the query. And okay, why this is not correct? Why this is correct? Okay. So we are getting the name and we are getting this filter. Okay. Um, we are using the indexing here using lock. Okay, I thought this is not correct.
If it was iLog, then it would have been wrong, right?
Yes, then it would be wrong. Which of the following can be used to find employees with the highest salaries? So again, we'll create a filter with the maximum salary, and then we'll figure out their names or the whole. Here, like we are getting index max, so index max, idx max will give us the index of the maximum value, and largest one, again it will give and largest 1 comma sales. That means it will give us the highest salary, the first highest salary of like first highest value of the sales column. And this is a basic filter. So no one has any doubt in these questions, right? These are some basic. And df group by region. Okay, a group by region sales mean, what does this do? And can anyone tell me what will this code will do?
They will go according to region, and the sales number will be sort of in Y column.
Okay, so what will be the result eventually we will get?
We'll get mean of sales from each region.
Right, average sales from each region. Okay, basic thing. Now let's move forward to next one. Okay, now the common data, we have this data, we need to output this value. Okay, just that they have added some expression. So what would be the answer for this whole?
Sir, 24.
Okay, 24. I just need to calculate. The shape will be 4. 5 into 1 2 3 5. The shape would be 25 and we have only one NaN value, so answer would be 24, right? Insulin dot value counts. Okay, what would be the answer for insulin value
Sir,
count
3.
length? T dot log 0. Okay, the
3.
first 3. Yes, the 3 and the index would be, here we are using log. If we use ilog, then yes. So the how we are getting 3 exactly?
Sir, actually this insulin, it will that do this method value counts, and the first value it will count the 0 value, and with the number of occurrence of 0 is 3.
Right,
After that 94 will come and the value it will be 1 168 1.
right. And value counts gives us the data in descending order, right? Depends upon the occurrence. So then we are getting 3. What will be the output of the following code? So we are selecting all the rows of the fourth of the last column. So we just need to find out the mean here, right? For this one.
Yes, sir.
Okay, it's a very simple. And how many columns have data type as float?
Sir, 2.
Okay, yes, 2. And what is this? Okay, the first is this column, BMI. What is the second column with the float?
The last one, because by default np.nan will be,
Right,
yes,
is the
float.
float. Yes, is a float data type. What will be the output of the following? So we are querying with the glucose greater than 100, taking the first two values and taking the last value, and then okay, then we're just taking the value from the first row and the second column. Okay, glucose should be greater than 100. So for greater than 100, we'll get this first row, third row, and fifth row. Then we are taking the head 2. So that means we'll have 148 and 183. Then tail 1. We'll get 183. And 183 after that, we need to do one more thing. Yes, 0, comma 1. I log 0, comma 1. So what we will get eventually?
64.
Right, 64. For the first column, and that, yes, 64. Basic questions. Now we have the parameter grid. Okay, for different parameters, how many unique combination? Okay, uh you guys tell me how many unique combinations will be there and how. Okay, anyone?
Sir, in first one, 3 into 5, which is 15, and in second one, 2 into 3, which is 6. Then we add up, so
Right,
21.
we are adding up because we are having different set of parameters. Okay, so the first set is the first dictionary, the second set is second dictionary. When we have only one dictionary, then we simply multiply all the like all the list of the parameters. When we have multiple dictionaries, then we like first find out the combination for each dictionary and then we sum up all these values. Okay, so that's why we are getting 21. How to make SGD regressor stop after 1000 epochs? To set max iter value as 1000. Just one thing, the iteration and epochs both are the same. Okay, iterations and number of times the model is running, the epochs, all these are same terms, but the actual, we can say, the parameter name is max iter. Okay, so just make sure ki max iter is the only like n iter, max iter is the term which is used in scikit-learn. Okay, just remember this one. And we have this data. Which one of the following can extract features from the above data? Okay, dict vectorizer, uh, hashing vectorizer, and feature hasher. Why cannot we use these two? Anyone? Okay, when do we use hashing vectorizer? Okay, let me check it once. Hashing vectorizer. So, okay, it turns a collection of text documents into a sparse matrix. Okay, yes. Find the token name. Okay, so we'll get some hash value for each of the value when we have some text data. And what about the feature hasher? Symbolic feature names into sparse. Okay, symbolic feature names. Okay, are these both same or somewhat different? Um, okay, there must be some difference. Uh, okay, I'll look into it. If anyone of you knows about it, do reply. Like, just you can directly tell us. Okay. Now the next one. Which of the following is an example of ordinal value? So the ordinal, we have some order. For blood type, we do not have any order. For gender, for height, we do not have any order. For height, like those are not categorical data. For satisfaction, we have some order, or for ranks, basic data kind of question. Uh, which of the following method is used to find the predicted probability of each class of training samples using a trained model, SGT classifier? Okay, for each class, let's say we are having two or more classes and we need to figure out the probability of getting each class. Then we will use predict underscore proba, which will give us the probability for each of the class of the respective sample, whatever sample we are passing. It will give us the direct prediction that can either be 0 or 1, but it will give us the probabilities. And yes. The next question, ridge classifier, normalizer, false. If we want to apply the ridge classifier with no regularization, okay, you guys tell me what parameter should we set here? If we want to apply ridge classifier on this with no regularization, what parameter what parameter should we set as 0? We have just discussed it. Anyone knows?
Sir, we use alpha.
Yes, alpha. Okay. The same thing, no text feature is the okay. We are using linear regression, leave one out as the CV and linear regression. Okay. For a data set of 1000 data points and 100 features, uh, the following code will generate how many models? Okay. How many models do we get with the like 100 data points, 1000 data points and 100 features?
Sir, it is using leave one out. That's why 1000, because it will consider one for testing
Right,
and others for the training.
right,
1000 model.
right. So we'll get 1000 models, very basic. And which of the following code snippet correctly applies lasso regression with regularization? Okay, again the same question.
Alpha equals to
Right.
0.1.
Very basic. Consider the following polynomial regression. What is the effect of include bias?
It
Okay.
will not be there.
Yes, the bias term, it will not be there, and the bias is that the constant term 1111, so we will not get that particular column. It will not be there. And what is the purpose of max depth? We have already discussed it, right? Given the code below, the following statement is true about criterion. Okay, what does criterion criterion parameter do? Anyone? Okay, again, just take some basic intuition. We split the tree into some basic criterias and all.
how better it would be.
Right. So if we like here we are using MSE, that is mean squared error. If the mean squared error is, let's say we have some value, let's say some 500 value. If it is more than 500 or something, then we will split further. If not, basically we will use that particular criteria, okay, to split the trees further, to check the data, to check the samples, okay. It determines a function to measure the quality of the split, right. uh, it specifies the number of features. No, it sets the strategy to choose split. It controls. No, this is not. No, the strategy is different. The strategy can be which kind of entropy which we are using. Which of the following code random forest classifier with 100 trees and bootstrapping enabled? Can anyone tell us, like, what would be the, like, how should we initialize the random forest here with this requirement? Okay, so how would we set 100 trees first in some classifier? Anyone?
An estimator.
Yes, an estimator says 100. And bootstrapping enabled, this is just a boolean parameter.
True.
Bootstrap, yes, bootstrapping enabled means bootstrap equals true. So this last one. Now the bagging techniques combines multiple models trained upon different subsets of data. The boosting model trains the model parallelly, focusing on error made by the other model. Which statement is correct and which is not? Okay, how the first statement is correct? Can anyone explain? Um, okay. The bagging techniques combines multiple models based on different subsets of the data. I'm really not sure about it. I cannot exactly provide you the reason uh, for the second as well. Anyone knows about these
The
two statements?
second one is false because the boosting is a sequentially. So after training the first model, then it focuses on error, and after like doing analysis of second model, it takes care that the error which
Okay,
was made by first model will not be
okay, okay.
continued.
All right. So it should, like, it trains the model sequentially, not parallelly. Okay. And okay, so the statement 2 is false. For the statement 1, we don't know. Okay, now let's move to the further. How does algorithmic clustering handle outliers? That I have done like very rarely. Anyone knows about this clustering method? Okay, let's check it out. Bottom up hierarchical. It starts with each data point at its own cluster and closes cluster until a single cluster remains. Okay. So outliers to the nearest cluster. How do you, okay. So if we have some visual, that would be great. This one. So it first starts with the, okay, let me open it. Yes. So it first starts with the these two values, then it will like combine the other clusters, then it will create this particular, like the Venn diagram, right? It grows eventually, and like the fourth one is kind of handling the outlier. Okay, so it is kind of it assigns outliers to the nearest clusters, so it is taking that outlier as well. And what is hierarchical clustering techniques that start with the same definition which we have just seen. Okay. Now in k-means clustering, inertia is the sum of square distance, already done. ML task. Okay, which of the Okay, so first we are reading the data from a file. It has 7 columns. The last is the target variable, rows which has target values missing. Okay, then we are taking 70% of the rows in training set and rest in test set. We are taking the randomly. Then filling the missing values using KNN imputer with 3 nearest neighbors and training linear regression and finding the R2 score. Okay, we just need to tell whatever the code is correct. Okay, this is a very basic thing. इसमें तो ना किसी को कोई डाउट नहीं होगा. I don't think we should read all the codes. If anybody has any doubt or something, you can ask. Okay. All right. Now next one, consider two classifiers. So we are having these two classifiers with these two different values. Okay. The data set is same. Okay. Basically, based upon this minimum sample split and sample leaf, can you tell me which one will be more deeper? Which one, like which classifier will have more depth, max depth, based upon these two parameters, minimum sample split and minimum sample leaf? Okay, एक थोड़ी सी just an intuition. Okay. Anyone, guys? Okay. Just one thing. If we have like some smaller sample split, smaller sample leaf, then it means ki we will grow more and more and more. So that means the max depth will increase. If we have like some bigger criteria stopping value in this sample split or sample leaves, then we will stop at like some certain value already. Let's say like as we have seen here only. If we have let's say we have some 10 samples only and we have 4 as the sample split, so we cannot go further when we reach some 4. Okay, so that means here max depth is 1. If we have some max depth as 2, then we will go further and further. Okay, so that means if we have like 3 here and 1 here, then we will go further and further. That will eventually lead to more depth, like here we have 3. So that is the thing. If we have like some smaller values in the sample split and sample leaf, that will have more depth. If we have some larger values, then we'll have smaller depth. So yes, and that can also be same, right? We cannot exactly say. Given the following code using, okay, is this clear, guys? Okay, am I audible?
Yes, sir.
Okay.
Yes, sir.
All right. Now the next one, given the following code using bagging classifier with k nearest neighbor classifier. Okay. With the following, so we just need to tell we are using 3 nearest neighbors. No, the base estimators are 30 and okay, the above codes using bootstrap. No, it is not using bootstrap. Bootstrapping model will be tested on out of the bag samples. Okay, we have not specified some kind of that parameter. Due to weights equals distance, each KNN classifier will treat all neighbors equal in terms of voting power. No, due to the weights distance, it will measure out the distance for each of the like nearest neighbors, and it will take all the like neighbors which are, it will do the voting on the neighbors which are having low distance, obviously, smaller distance. So okay, now the next one, voting classifier. Okay, this is an interesting question. What does the soft and hard voting parameter do in voting classifier? Anyone? Okay.
Sir, it will calculate the predicted probability.
Okay, the soft voting.
And hard works on major voting.
Okay, what is the major voting?
So like maximum value it will see.
Maximum value. Okay. So like we have these three different classifiers. Let's say one is giving the accurate, like uh, for a sample, two classifiers are giving one, and the last one is giving 0. And with the soft voting, what will happen? So it will take the, okay, with the soft voting, I guess it was something with the probability. Hard voting in voting classifier. Hard voting using the majority class. Okay. Average is the predicted value. Okay. Soft voting will take all the probabilities for all the classifiers, and it will take the average, and whatever the average will be closer to, it will uses that as the prediction. And the hard voting, it it actually do the voting, we can say, like it takes the majority value, the class which is having the highest votes. Okay, the based upon the average probabilities. Suppose that we use k-means clustering for 100 samples. The initial centroids k can be initialized in one such way is shown below. Okay, yes, random. 5 centroids are randomly initialized 10 times. Okay, this is the very simple thing. Like init specifies how like the centroid should be initialized, and how like how many times it should initialize, like that eventually kind of helps us model to, we can say, train better, that we pass in the n init. So again the parameter says itself what the values we need, or what with the values also we can say what kind of centroids we are having. And okay, data snooping. What is data snooping? Leads to biased estimation on test. Is it similar to data leakage? Anyone knows about data snooping? Okay.
No, sir.
Mm, so just again a simple Google that happens when a researcher without hypothesis, um, data phishing, p hacking. Okay. Okay. So it is for like manipulating the data. It increases the risk of, yes, data snooping. Like we are manipulating the data to lead better results on the test set. So leads to bias estimation on test set. That is correct. Leads to better estimation, no, on test set. So data snooping is kind of a cheating, we can say, doing with the training data for achieving good results on test data. But that increases the risk of false positives, like it is giving us uh, positive values which are not actually positive. Okay, so a simple thing. Which of the following algorithm may get impacted by feature scaling? Okay, this is one interesting thing. Linear regression, SVM, yes, how the support vectors and how much data is scaled. What about decision tree? Why it is not affected by feature scaling? Can anyone tell? Okay, the distribution of the data remains same. Okay, doesn't matter whether we like scale the data or not, and the decision tree will eventually split the data based upon the criteria which we have mentioned. and the naive Bayes algorithm. This uses the probability, and eventually the distribution, again the distribution remains the same if we scale the feature. The only the range changes, so it does not affect in the naive Bayes. Now consider the following code snippet using logistic regression with x and y. Class weight is balanced. Okay. Equal weights for both the classes. The model does not use any regularization. No. Um, the balanced model uses the balanced mode uses the value of y. Okay. The C indicates for a regularization that we know. Okay, the class weight is balanced. Yes, so class weight will be balanced, so it will balance the class weight. So if like the data is unbalanced, we can you set class weight as balanced to get like better estimation of the data, better predictions eventually in the logistic regression. Now the next one, which of the following statements are true? The higher near, this is a very basic question which repeats every time. Anyone wants to explain it, or if anyone have any doubt in this? Okay, I think not. Are we good to go with the next one? Okay, think we should. Okay, which options are correct for SVM support vector? Again, the very basic definition for SVM they are asking. We maximize the margin obviously, and support vectors are the data points nearest to the hyperplane. K means clustering algorithm. It is again asking for the theory. Spherical clusters, no. It does not automatically detect the most appropriate value of K. We pass in the K and we like use hyperparameter tuning as, or like elbow method. Okay. Okay, now this is an interesting question. Can anyone tell the accuracy? Okay, how many of you are still there? Can you guys give a thumbs up or something? Okay, only one. All right. No worries. Okay. So, well, this is basic for the like accuracy we can figure out just by checking the diagonal and summing up the diagonal divided by total. And they're asking for precision for label 1. So precision is true value divided by like all the how many of are like predicted as true divided by like how many of them are actually true divided by how many are predicted as true. So it would be 2 by 5. Yes. Okay.
Sir, how 5?
Okay, sorry, not 5, sorry, 6, 3 3 6. It would be 2 by 6. Okay. No, let me see the definition. Precision was, okay, I have noted it down. Precision is out of all positive predictions, how many were true? Okay, so out of all the positive predictions, okay, so this is positive predictions, how many are true? So 2 is in the numerator and we have 8, so 2 by 8, 1 by 4, which is 0.25. Okay, 0.25 is the correct answer. So we are looking in this particular column, we can say, and dividing the 2 by the all the sum of the column. And what will be the output of this code snippet? Okay, again we can simply plot it down and we'll get the answer like to which it is belonging, to which class it is belonging, whether it is belonging to 1 or whether it is belonging to 2. Any guesses?
1.
Yes, 1. Yes, because 0 is there, and then we have 1.5 as well. Only the one value for the 2 is 2. So the whole area, 75% of the area is covered with the 1 only. Now neighbors classifier. Okay, how many classes do we get here?
Sir, 3. Because in White we have 3
Right.
labels.
Right. Very basic question. XP feature matrix 1000 comma 5 and y with the 0 comma 1. Assume that 650 examples data belongs to 1. Okay. What would be the score? What would be the accuracy here with this code? How many of you have MLP project or have submitted it? I guess all of, if you have, then you must have submitted it. Okay, this is like the dummy classifier which everyone uses for the first submission. So most frequent means whatever the majority class we have, it will consider that as the prediction for all the samples. So we have like out of 1000 we have 650 for 1. Okay, so the accuracy will so it will classify all the samples as 1 because 1 is having the majority, right, above 0. So it will predict 1 for all the 1000 samples, and the score, which is the accuracy, it will be 65.65 we can say. And okay, recall. Now we just need to find out the recall and the other values. Okay, the precision as well. Okay, that's it. Again, we can put in the formula. And yes guys, just one thing, I had prepared this sheets, I guess when I was doing MLP. So it is kind of having all these scores and everything, like if we have some actual and predicted data, how can you make the confusion matrix out of it, and how can you calculate accuracy, precision, recall, and F1 score. So if you guys want it, you guys can like download it from this GitHub repo. Okay. Uh, so yes. Okay. Do you guys have any specific question or something? Like the time is already over. So
Can you explain how to calculate recall score?
okay.
Can you
Can
show that question?
all
Here
right.
above one.
Okay. Recall score
That is-
y comma. Okay. So the what is the definition of recall, or like what is the formula? How many how many of the actual true samples uh like how many actual true from the actual true samples, how many are predicted as true? So this is the definition of recall. If we see like out of all actual positives, how many were predicted true? Okay, so actual were like uh, the predictions for all the samples is 1, right? So if we create a confusion matrix for this, how it will look? Let's make this confusion matrix इससे सब clear हो जाएगा. So we have like 1000 samples. We have like two classes, 1 and 0. I'll plot it here. True or okay, sorry, actual and predicted, I'll do it here. And 0 1. For the 1 we are having 650. For the 0 we are having the rest, which is yes 350. And the prediction is y hat is like 1 for all the 1000 samples. So like if we create a confusion matrix, how it will look, where the 650 will come. Okay, let's reference this one. Very simple. So we have like these labels. First we create the these boxes, the positive, negative, or 0 1 something. So okay, if we keep actual here and predicted here, this is kind of a structure we'll have. Let's just match it. So I'll simply erase this one just to maintain uniformity. We'll have predicted here, actual here. All the samples which are belonging to 1 will come here, which is eventually the sum of these two rows will be 650. Okay, and the actual are 650 and the predicted are as well as 650. Okay, currently this, and here we have 350, and the sum here we have is, can anyone tell like how many are predicted as 0? Based upon the question, if we see, okay, anybody wants to guess at least?
No one is predicted as 0
Right,
because all are 1.
right, all are 1 because it is 1 for all the 1000 samples and we have thousands here, so we just match it. So we have 650 here, sorry, 650 here, and here we'll have eventually 0, and how many of the how many of the zeros which are predicted as 350, and here we'll have 0. Okay, so this is how confusion matrix looks like. What is the true positive here if we consider 1 as the positive? Can anyone tell what is the true positive? Okay, this is the true positive. Okay, and for this only, this is the, sorry, this is the false positive. False positive is this one, and this is true negative, and this is false negative. So false positives are those which are predicted as positive but actually they are not. So recall basically means out of like the actual positive predictions. Okay, sorry, the recall says out of all actual positive predictions. So that means out of all actual 1 classes, how many are predicted as true? So actual classes we have is 1, right? Because there we have 0, and here we have 650 which are predicted as true. So that means 650 by 650 plus 0, which eventually leads to 1. So that's why we have recall as 1. Is it clear? Okay, guys, is it clear or not? Okay, take care. Then we have the precision. We can again calculate the precision in the same manner. The recall is done in this manner and the precision will be done in this manner. Like out of all the, okay, I'll just clear it once. Precision is out of all positive predictions. It will take predictions as the base. How many are actually true? This is for precision. For recall, it will take how many out of all actual positives, how many were predicted true. Okay, so like it will take actual as the base, the actual y values as the base, and for precision it will take the predictions as the base. Okay, so this is the difference in precision and recall. Okay, anyone wants to like discuss or know anything regarding MLP or any specific topic or something? Okay, all right, then we should end this session. Okay, and just one thing, the recording of this session will be uploaded to my YouTube channel, and apart from that, if you want to like see more explanation of the PYQs, I have already created a playlist. I already have a playlist of, I should, yes, so yes, this is the playlist. Here I'll add this today's session as well. You guys can watch this session number 21 as well. Okay, there like uh, we have done I guess 2 to 3 PYQs in that session also. Okay, so this is for your practice, and all the best guys for your enter, and I'll upload the recording of this session in the YouTube channel. Okay, so you guys can subscribe to it. And that's it, and all the best, guys. Thank you.
Thank you.